This is lesson 8.6, slope. Slope is a number that describes the steepness of a line. It is the ratio of the rise or the vertical change to the run or the horizontal change of a line. So slope is just equal to rise over run. Rise is the vertical change, vertical is up and down. Run is the horizontal change. Remember, horizontal is left to right. Now this might sound a little familiar. This might sound kind of like what we just did in the last two lessons, and that's because it is. Slope is the exact same thing as rate of change. Usually we use slope to refer to something like a line on a graph, and usually we use rate of change to talk about something that has some sort of a real world meaning. Now, that's not always the case, that distinction, but they are very, very closely related. If you notice, with what we did with rate of change, we were always finding, for the top part of that ratio, we were always finding the difference in the y values, and the y values are graphed on the y-axis, up and down. That's the vertical change. And then the numbers in the bottom of the ratio were always from the x values, or the horizontal axis. So these are indeed very, very, very closely related concepts. Okay, so let's look at example 1. Find the slope of a ramp designed to race model cars that rises 6 inches for every horizontal change of 16 inches. And there's a picture to go with this one, though you really don't need it. Slope is rise over run. So the rise in this problem is 6 inches. So that's 6 over the run, which is 16 inches. And typically for slope, most of the time, we prefer to leave our answers as fractions reduced in lowest terms. So while I could go ahead and divide this and get a decimal, that's not really the way we like to see slope written. So instead, I will just reduce this down to 3 over 8. And that is the slope of this ramp. Okay, so do the same thing for the first try it yourself problem. Find the slope of a hill that rises 30 feet for every horizontal change of 1,500 feet. Pause the video, work through that problem, and when you're ready to check your answer, hit play. Okay, for this one, the slope you should have gotten, reduced to simplest form, should be 1 over 50. Alright, let's look at example 2 and see what this looks like on our graph. Example 2 says to find the slope of each line. And remember again that slope is equal to rise over run. And there are 2 points labeled on the graph for us. So we want to know how much the graph rises and how much the graph runs. But then the question is, well, which point do you start at? You can start at either point. You should get the same answer. However, most people, if you start at the point on the left, when you go down to calculate the rise, you'll remember that going down is negative. And then run from left to right will be positive. However, if you started at this point, your rise would go up, and then run would go to the left. And a lot of people forget that when you're dealing with x values, going to the left is negative, because that's just not as easily associated with negative as up and down is. So, just a good habit to get into for slope, always start with the point that's furthest to the left on the graph. That way you only have to worry about whether the line goes up or down, not whether you're counting left or right also. Alright, so we're going to start at the point to the farthest to the left. And we want to calculate the rise. So for this point, to get from here to here, we actually need to go down 1 unit. So the slope will be negative 1 over the run. So from here all the way to here is 1, 2, 3, 4. We have negative 1 over 4, or just negative 1/4. and that is the slope of that line. Okay, let's do another one. Alright, so again we want to start at the point furthest to the left, so we'll start at this one, and then rise, let's see, so that's up 1, 2, 3, and then run. From here to here is just 1. So that's up 3 to the right 1. Up 3 to the right 1. And then we can reduce this, or really just write it in a more simple form. 3 over 1 is the same as just 3. Okay. Do the same thing for try it yourself 2a. Find the slope of that line. Pause the video, find the slope of the line, and when you're ready to check your answer, press play. Okay, the slope you should have gotten for this one should have been negative 4 over 5. Okay, let's continue on to the next page. The slope m of a line passing through points x1, y1 and x2, y2 is the ratio of the difference in y-coordinates to the corresponding difference in x-coordinates. And then you have this formula, m equals y2 minus y1 over x2 minus x1, where x2 does not equal x1. Whew, that's a lot of stuff, and it probably didn't make a whole lot of sense to you. So let me see if I can make this a little more easily understandable. This is giving you a very general version of this slope formula, because let's face it, you don't want to have to graph every single pair of points that you ever wanted to find the slope between. Slope is a very, very, very big concept in algebra, and it's something you'll see over and over and over again, and the slope has very, very useful meanings to it. You will not want to have to graph every single point, every single pair of points in order to find slope. Imagine, if you need further rationale, imagine you had 2 points that had very, very large numbers. You would not want to have to graph those and then count the rise and the run. So that's where this formula comes from. It makes this easier to calculate without having to actually graph. So first of all, let's talk about the coordinates of these points. This is not the same. You see like this x2, that's not the same as this. Not the same. This is a 2 up at the top. This is an exponent. This 2 is a label. It's just to distinguish it from this x coordinate. So if you look at this picture here, this is one point on this graph here, and this has an x coordinate and a y coordinate. And it's the first point, so we call that x1 and y1. These coordinates here are the coordinates for the second point on the graph. And because it's the second point, the x-coordinate and the y-coordinate will be called x2 and y2. The labels, again, are just to distinguish one from the other. So these are not like exponents, they're just labels. Okay, so remember we're talking about the rise over the run. So the rise is the change, since this is the y-axis, up and down, this is the change in the y-coordinates. So if I wanted to find the change in these, I would subtract y2 minus y1. Same thing with run. This is the change in the x-coordinates. So if it goes from x1 to x2, we'd do x2 minus x1. And that's the same thing we were doing, remember, with rate of change. So this is really not that different. So this is the formula that you'll use when you have something where you don't actually have a graph where you can count rise and run. You just have the coordinates of points. Alright, lines that rise from left to right have positive slopes. Lines that fall from left to right have negative slopes. So for example, this one drawn on this graph has a negative slope because from left to right, the graph goes down. Horizontal lines have a slope of 0, and vertical lines have an undefined slope. Okay, so these two, students tend to get these very, very, very confused. The best explanation I can think of for this, the two things that that come to mind as far as a real world sort of example of this when slope is involved are roads and roofs. So think about roads. If you were to drive on a road and you're going uphill on that road, that would be a positive slope. If you were going downhill on a road, that would be a negative slope. Uphill is positive, going up. Downhill is negative, going down. Now you could drive on a road that's completely flat. That would have a slope of 0. It doesn't go uphill, it doesn't go downhill. It's just a slope of 0. But think about a road that would actually be a vertical line, straight up and down. We don't make roads like that for a reason. You can't drive on a road that is straight up and down. And that is what makes that a slope that's undefined. And we'll see mathematically in a minute why you get that. But if you have trouble distinguishing between a slope of 0 versus a slope that's undefined, think about roads. Same thing with roofs. Roofs can go up, roofs can go down, they can slant up, slant down. You could have, on a lot of large buildings, think like skyscrapers and things like that, you can have a flat roof, no slope whatsoever. Again, slope of 0, horizontal. You would never build a roof straight up and down. We call those walls. Those are not roofs. So that would be an undefined slope. So that should help you distinguish between those 4 different types of slopes. Alright, so let's see how this formula works with coordinates of points. So for example 3, we want to find the slope of the line that passes through each pair of points. Okay. So the first pair of points is the point B at 2, 7, and the point C at -3, -2. And our formula says that m is equal to y2 minus y1 over x2 minus x1. Now what really helps with these is to actually label the points, because you see how these are in a different order, x1, y1, x2, y2, than what we have in the formula. So when you're going around and trying to fish for the right numbers to put in the right places, it'll be really nice to have these numbers labeled. So this is x1 and y1, the x and y coordinate of the first point, and this is x2 and y2, the x and y coordinate of the second point. So now, we've really taken all the thinking out of this. You're just filling in numbers where they belong. So y2 is -2, minus y1, which is 7, and then x2, which is -3, minus x1, which is 2. So -2 minus 7 is -9. -3 minus 2 is -5. We want this in simplest terms, so the 2 negatives here will cancel, and this is just 9 over 5. And because this represents the ratio of the rise to the run, it does not make sense to change that to a mixed number. You should never see a slope written, like in this case, as 1 4/5. That does not make sense. This has a rise of 9 for a run of 5. So this, if I were to graph these 2 points, this line would rise 9 units for every 5 units in the horizontal direction. So leave this as an improper fraction. Do not change slope to a mixed number. Okay, let's try the next one. So again, we have our slope formula, y2 minus y1 over x2 minus x1. And we want to label our 2 points. This is x and y of the first point, x and y of the second point. And then substitute. So y2, which is 2, minus y1, which is 5. x2 is 4, minus x1, which is 5. 2 minus 5 is -3. 4 minus 5 is -1. And again, we'll reduce completely just to get a slope of +3. Okay. For C, same thing, still finding slope. So we'll write down our slope formula, y2 minus y1 over x2 minus x1. Make sure we label our points, x1, y1, x2, y2. And now we substitute. Y2 is 7 minus Y1, which is 7. X2 is 2. X1 is 5. So we have 7 minus 7, which is 0. And then 2 minus 5, which is negative 3. And when we divide 0 divided by negative 3, that just gives us 0. So the slope here is 0 between these 2 points. Remember, that means that this is a horizontal line. And it's really not part of the answer, that's just there to remind you that when you get a slope of 0, that's because you have a horizontal line. Okay, one more. Okay, again, our slope formula, y2 minus y1, or x2 minus x1, and label the points, x1, y1, x2, y2. And then substitute. Y2 is 3 minus y1, which is negative 4. Now, I'm going to point this out because a lot of people make this mistake, and I'm hoping that you will not be one of them. We have to be very, very careful right here when we write down the numbers in the formula. Notice that there's a minus in the formula, so we have a minus here. And then y1 is negative 4, so I have the negative with the 4. Be careful that you don't just write down 3 minus 4, because the y-coordinate is not 4, it's negative 4. So you have to have the subtraction from the formula and the negative from the number. You have to have both. Alright, let's get the denominator. x2 is 7, and x1 is 7. Okay, so here 3 minus negative 4, that's like 3 plus 4, so this is 7 over 7 minus 7, which is 0. Okay, now back here where we had 0 divided by negative 3, this we could do. 0 divided by anything is always 0. This, on the other hand, is not good. In fact, I can guarantee you if you put that in the calculator and you try to ask the calculator, what's 7 divided by 0? The calculator will not be happy with you. Calculator doesn't know what to do with this. Division by 0 is undefined. It makes no sense in math. So when you get something like this, the slope is undefined. And we already know why that slope is undefined. That's because this represents, these 2 points represent a vertical line. So the slope is undefined. Okay, there are 3 problems on this page for you to try yourself, so go ahead and pause the video, work through all 3 of those, and when you're ready to check your answers, hit play to compare. Okay, for the first one, the slope you should have gotten should be negative 1/5. For the second one, the slope is undefined. And for the last one, the slope is 0. And please make sure that you have work shown for all 3 of those as well.